Hello grade 10s. This video is just going to go over the corrections from exercise 3.2 for the application questions. So the first question, you can see it says chains of squares can be built with matchsticks as shown on the right. Okay, I've drawn the matchsticks. Please make sure that you've also drawn these matchsticks into your book when you're answering. Okay, it just helps so that you are able to actually make notes on it, and then again, like I said, you can see the diagram next to what you're trying to answer. Okay, so the first question basically says to you, create a chain of 4 squares and then how many matches did you use? Okay, so basically what you're going to do is you're going to take the chain that you've already drawn, your 3 chains, and you're going to repeat them, but then you're going to add additional chains in order to draw the next one. So if you did it correctly, you should have drawn 3 additional chains, and then it said how many matchsticks were used. So you're basically now going to count. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so you would have needed 13 matches to add to the next one. Then it says create a chain of 5. Okay, so 5 would have again been to repeat this. So you would have redrawn the 4, and then you would have drawn the additional 3 matches. Okay, then you would have counted again, and I'm sure you would have noticed that now you have 16 matches. Okay, then the third question says determine a general rule for finding the number of matches in a chain of n squares. So they want Tn. Okay, so let's take down the number pattern. I see the first one I have 1, 2, 3, 4. The second one you have 4 plus 3, which is 7, and then 10 and 13 and 16. Okay, and so it continues until you get Tn. So Tn is going to be Dn plus C. I'm sure you can tell the difference is 3. Okay, because we just keep adding 3. So if C is equal to T1 minus D, then 4 minus 3 is just 1. So Tn is going to be 3n plus 1. Okay, that is the general term for that one. Then it says, now determine how many matches will be needed to build a chain of 100 squares. So all you're doing is you're just calculating T100, which is going to be 3 times 100 plus 1, which is 301. Okay, matches. Okay, hopefully that wasn't too difficult. Okay, you can see the main thing is just being able to utilize shapes in order to do the number patterns. Okay, then B, I've drawn the squares already. So again, make sure you've drawn in the squares. It says in each diagram below, there are shaded squares and white squares. Okay, determine the number of shaded squares in diagram 300. Okay, so first of all, we need to figure out how we're going to find the number of squares in 300. We would have to first find Tn. So in order to find Tn, we first need the number pattern. So we'd say, okay, the number pattern, there's 1, 2, 3 shaded squares, and then 1, 2, 3, 4, 5, 6, and then 3, 6, 9, and so on. So hopefully you can tell that the common difference here, I'm just adding 3. Okay, and then C is going to be T1 minus D, which is 3 minus 3, which is 0. So then this is just the general pattern there. Okay, you don't have to add a C value. So they said they want to know how many there are in the 300th pattern, which is 3 times 300, which is going to be 900 shaded squares. Okay, and then which diagram will contain 1500 shaded squares? So basically they're asking n, if Tn is 1500. So if Tn is equal to 3n, then 1500 will be equal to 3n. So n is just going to be equal to 500. So therefore T500 is going to be equal to, yes, T500 is equal to 1500 squares. Okay, then for C, let me move this up because I don't want to go to a new page. Okay, so you can see that for number C, it asks you to determine the nth term of the following nonlinear sequences. So the first one is 1, 4, 9. I don't know what's happening with the pen. Let me just write it again. C is going to be 1, will be 1, 4, 9, 16, 25. So again, hopefully you can see that this is the special number pattern. It's the square number pattern. So the general rule will be Tn is equal to n squared, as this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, then for the third one, it's 1, 8, 27, 64. So hopefully with this one it is a bit trickier, but you should be able to pick up that this is actually a cube pattern. So then the general rule Tn is just going to be n cubed. Okay, so these are the two special types of number patterns that we can ask you in grade 10. Okay, so make sure that you remember it and you are able to identify it. Okay, and that's essentially the corrections for exercise 3.2. Okay, so the next lesson is going to be on a brand new topic, and I'll see you then.